and it could be a point which is the point of inflection. In other words, it's not changing its behavior, but it's still the tangent line has a slope 0 here. So if you differentiate a function and equate it to 0, you're gonna get what? You're gonna get the points for which you have to think of that, you know, that whether it is a maximum, minimum, or a point of inflection. Okay? This is an important thing that we should keep in our consideration. So now, so I hope we understood critical point. So the critical point is the point where the derivative of the given function is 0. It could be maximum, it could be minimum, it could be point of inflection. But Fermat's theorem says that if you have a maximum and minimum at a point, it must be a critical point actually, because the derivative of the function at that point is 0. Okay. Now here is a not so well-known method. Okay, it's called the closed interval method. Closed interval method for finding extrema. By the way, extrema is a word that is generic actually for maxima and minima. So extrema means maxima or minima both. Could be maxima, could be minima. So how to find an extrema of a function actually? Okay, and here the extremas are going to be the absolute extrema, absolute maxima and absolute minima. So this is a recipe for finding absolute maxima and absolute minima. Okay? So here is the algorithm, so the method. So to find, and we will illustrate this method through an example, to find an absolute max or minimum of a continuous function, because extreme value theorems tells us that if you have a continuous function on a closed interval, it must have a maximum and minimum. The question is how to find it. So this method, this algorithm is telling you that how to find it. So maximum minimum of a continuous function on interval a to b. Interval a to b. First of all, step 1 is to find the critical numbers in the interval a to b. In other words, within that interval a to b, excluding the endpoints, try to find the critical points. And what do you mean by critical points? The points where the derivative of the function is 0. That is, solve f prime of c equal to 0. Okay? Yeah, f prime of x equal to 0. Okay, the first step is find the critical point, and for finding the critical point, compute the derivative of the function and equate it to 0. So that will give you the critical points. Step 2. Step 2. Find the values of function at endpoints A and B. Okay, so first find the critical point and then find the values of A and B at endpoints. Okay. say the critical point that you find here is x equal to c. Let's call that. So you solved f prime of x equal to 0 and the solution is x equal to c. Okay, so you found the critical point and then compute the value of the function at the endpoints a and b. And now compare the values. Step 3, compare values f of a, f of b and f of c, where the c is the critical point that you found in the first step. After comparison, in these three values, there may be more critical points actually. In these 3 or 4 values, the biggest value is going to be the absolute maximum and the smallest value is going to be the absolute minimum actually. So simple. Find critical points, compute the value of f at endpoints a and b, and compare the values f of a, f of b, and f of the critical point, and see what value is the biggest and what value is the smallest. The biggest value, the largest value would be the absolute maximum, and the smallest of all these values is going to be the absolute minimum. Absolute minimum. And so this is an algorithm. And you see that this algorithm works actually. Why this algorithm is really a sensible algorithm? Think about it. Let's try to draw, let's take an interval a to b and let's try to draw some curves. So for example, if I have a curve like this, okay, so you're going to say that what are the points where you have, where your critical points inside the interval a to b, where you have the critical points. So you're going to say you have one critical point here and okay, maybe one critical point here, something like that. So you have these 2 critical points, or maybe there is only one critical point. Now, if you compare this value with, say, these values, this value, this value, this value, you will see this is maximum and this is minimum. This is maximum and this is minimum. So this is x equal to c, where you have maximum, and this is f of b, where you have minimum. You can make any other curve. You can make, for example, any other curve. So let's make, for example, let me make, say, this curve. What points are the critical points? This point is the critical point. So if I found this point or this value and I computed these 2 values, what will happen? So this is f of a, f of b, and this is f of c, where the c is the critical point. So when you compare these 3 values, you're going to say this is the maximum actually, absolute maximum. Okay, absolute maximum. And whatever is the smallest of the both could be equal as well. Okay, so imagine this one is even more smaller, then this is absolute minimum, absolute maximum and absolute minimum at endpoint. Okay, so the recipe works. Find the critical points, find the values at endpoints, and compare the values of endpoints with the values of critical points actually. That is going to decide the maximum and minimum value. So let's have an example. Let's do a mathematical example. You see, this is important, that we must understand, we must go through the process, that why these algorithms are the way they are. Otherwise, there is no point of just memorizing them. Just try to make sense of it. Everything is really logical and you can make sense of it through pictures. Pictures are important. Okay. So for example, consider a function, say f of x equal x minus 2 sine x. Okay? And consider this function x between 0 to 2 pi. Alright? And what is our task? Our task is to find the absolute maximum and absolute minimum of this function. First of all, is there an absolute maximum and is there absolute minimum of this function? The answer is yes. Because this is a function that is continuous and it is defined on a closed interval. So the extreme value theorem tells you that if you have a continuous function defined on a closed interval, it must have an absolute maximum and absolute minimum. So the question is how to find it. The answer is just follow the steps. So the first step is find the critical points. And to find the critical points, what we need to do is just compute the derivative of the function and equate it to 0 and solve it. So what would be the derivative of the function? The derivative of the function is 1 minus 2 sine x equal to 0. So you're going to have sine x equal to 1/2. Then what we have to do, we have to look at between 0 to 2 pi, what are the points, what are the x that gives me sine x actually. Okay? So the points that gives me sine x is x equal to pi by 3 and x equal to 5 pi by 3. So I hope that you know how to find so you can do the inverse trigonometric function. So x is sine inverse 1 upon 2. Either you can look it into the trigonometric table actually, and you can see that at x equal to pi by 3, sine x is 1/2, and x equal to 5 pi by 3, sine x equals to 1/2. So these are the 2 points. So you're going to say these are the 2 points that are the critical points. Critical points. Okay. What is the step 3? Step 2. So the step 2 is find the value of the function at the end points of the interval. So let's substitute, say f of 0. So the f of 0 is going to be 0 minus 2 sine 0. So you get a 0. And what is f of 2 pi? So f of 2 pi is going to be 2 pi minus 2 sine 2 pi. And sine 2 pi is again 0. So the output is 2 pi. Okay. At the step 3, so what we need to do this in the step 3, the step 3 is compute. So we already computed the values at the end points. Now compute the value of the function at, what do you call these points? X equal to pi by 3 and x equal to 5 pi by 3. And see which value is the biggest and which value is the smallest. Step 3. So if I compute, for example, f of pi by 3, so it's going to be 2 minus sine pi by 3. Okay, so it's 2, no not 2 but pi by 3 minus sine pi by 2 sine pi by 3. 2 sine pi by 3. So you can pull out your calculators, and it turns out that this is equal to minus 0.684. Okay, something like that. And what is f of what do you call 5 pi by 3? So the 5 pi by 3 is going to be 5 pi by 3 minus 2 times of sine 5 pi by 3. Okay, and it turns out to be a number that is 6.98. Okay. And now if you compare the values of the function at critical points and the values of the function at end points, out of these four values, which value is the biggest and which value is smallest actually? So you're going to say this is smallest value because it is negative, and this is 2 pi. So 2 pi is going to be what? Okay, so 2 pi is 3.14, so it's going to be 6.2 something actually. Okay, so this is the smallest value and this is the largest value. Okay, so this is bigger than 2 pi. So what we're going to say? We're going to say the conclusion is that f of x has absolute minimum at x equal to pi by 3, and the minimum value, what is the minimum value? Value is f of pi by 3, which is minus 0.684. So that's first conclusion. Second conclusion, f of x has absolute max at x equal to 5 pi by 3. Why I am writing it? Because it is important that we must write things in a comprehensible manner. So just putting the numbers is not enough. You need to talk about them. At x equal to 5 by 3 and max value of the function that it takes at this 5 pi by 3 is 6.98 actually. 6.98. Okay, so this is one of the examples that given function we computed critical points, we computed the values at end points and compare them, and it turns out that these two are the big values. So the maximum is pi by 3 and minimum is 5 pi by 3, and the maximum value is minus 0.684 and maximum. So you have to always differentiate between maximum point and the maximum value. Minimum point and the minimum value. Minimum point is the input where you have the maximum minimum value, and a maximum point is the input where you have maximum value. So all this is important actually. Terminology is important. Let's do one last example. Yeah, this example is about the Hubble Telescope. Okay, so there's another example. So on April 24, 1990, so there was a telescope launched by NASA. It's called the Hubble Telescope. It's called the Hubble Telescope. Okay. And there was a model developed for it, or it was modeled actually, that the velocity of the rocket, the shuttle that took that Hubble telescope in the space was this. In other words, its velocity was modeled at, say, v of t equal to 0.01302 t cube minus 0.09029 t square. So when you are doing what you call astronomical calculations, every single zero and dot is important. plus 23.61 t minus 3.083. So this was, so it's a cubic curve actually. Okay, so it's like the velocity increased, stabilized, and then again increased actually. Anyway, so it's a cubic curve actually. So what is the question? So using this model, the question that we would like to answer, using, and this is the velocity of the shuttle, the rocket that it took actually, that Hubble telescope, that took Hubble's telescope in this space. Okay. So the question, using this model, try to find the maximum and the minimum acceleration, absolute maximum and minimum acceleration of shuttle. This is what the question is. Okay? So I have a model for the velocity of it, the way the velocity is changing for the shuttle, and our task is to find, during this journey, what was the maximum acceleration that was achieved by the shuttle, and what was the minimum acceleration that was achieved by the shuttle. So what we're going to do, this is same as we're going to apply the same method, but first of all, if this is the velocity, what would be the acceleration of the shuttle? So we know that acceleration is the derivative of the velocity with respect to time. Okay? So if you compute the derivative of the velocity with respect to time, so it turns out to be this 0.00390 t square, so 3 times of this minus 2 times of this. So you can calculate it. You shouldn't believe on the calculation of book or me. 58t minus plus 23.61, yes. So this will be 0, so we're going to have 23.61. So this is the formula for the acceleration. And what is our task? Our task is to find the maximum and the minimum values, the maximum and minimum, at what instant at what time the function achieved, the shuttle achieved its maximum acceleration, and at what time the shuttle achieved its minimum acceleration, and what was that maximum acceleration and minimum acceleration. So we need to find both actually. So the time and the maximum and the minimum acceleration. So how are we going to do? We're going to do the same. So the first step, find the critical point. Okay? Find the critical point. So what would be step 1? How to find the critical point? You need to differentiate your given function and equate it to 0. And try to find the value of the t. So if you're going to differentiate this again, what you're going to get 2 times of this minus 0.1805, so this will be 0. So this will become what? So this will become 0.007812 t minus 0.18058, and this is equal to 0. And from this, okay, by the way, I can say that time was measured in feet per second actually. Okay, so the time is feet per second. The time is going in the velocity, and v of t is and the unit of the velocity is feet per second actually. So the time, the critical time that where it reached is going to be what? That you need to divide this by this. In other words, 0.18058 is divided by 0.07812, okay, which is going to be 23.12 seconds actually, 23.12 seconds. So this is step 1. What is step 2? Okay, step 2 is to compute the value of the acceleration at the endpoints. Okay. So we need to also have something that I forgot actually to mention, that the time, okay, the time of shuttle to get accelerated, or the t, is between 0 to 126 seconds actually. Okay, so this is the time interval. This is the domain for this function actually. Okay, but you can read from the book that there is an explanation for why t0 and why is t126 actually. Okay, so what you need to do, you need to compute your acceleration at 0. So we computed the acceleration at 0 and it turns out to be, so I need to substitute 0 here, so what are you going to get? So everything will go away, so you're going to have 23.61, and then compute the value of A at 126, which is 62.87, and then step 3 is that compute the value at is 23.12, which turned out to be 21.52. So what does this mean? Where is maximum and where is minimum? So you're going to say the maximum acceleration, the minimum acceleration was at the beginning. No, the minimum acceleration that the shuttle achieved was after 23.12 seconds, and the acceleration was 21.52 feet per second square. And the maximum acceleration that shuttle achieved was after at the 126th second, and its maximum acceleration was 62.87 feet per second square. Okay, so 126 is maximum. 126 second is the maximum, is the instant where the acceleration of shuttle become maximum. And what was that acceleration? 62.87 feet per second square. And 23.1 at the 23rd second, or between the 23rd and 24th second, the acceleration of the shuttle was minimum, and it was 21.52 feet, what do you call, per second square, while interestingly, it was not minimum at the beginning when the rocket was launched actually from the station. Okay, NASA. So I hope this is making sense to you. So there will be some exercises for you to do the things in this manner actually. So I hope this is making sense to you. We'll carry on discussion.